Again, thanks everybody for being here in Nashville. I hope the food's been good. There have been a few hiccups, there always are, but it's great to see some of you just jump up and say, what can I do to help? That's what we've always come to expect out of this group of people. So, fun. As most of you know, I have been talking about finance and finance-related things for a long time, having edited the 12C Platinum Owner's Manual to put in algebraic stuff at the time. Remember, they first sold that with an RPN-only manual. I put algebraic on the keyboard if they weren't going to update the owner's manual. That's what I asked them, and they said, can you do it? I'm sure. But I thought I would add something else to the time value of money discussion, and that is actuarial math, actuarial science, adding mortality, if you will, to the time value of money. Now, I'm going to put this up here first. I want to have a disclaimer. Okay, hopefully everybody agrees with all of that text. Take a moment so you can read it. Okay, good. Now, obviously, nothing in here should be taken to be anything you rely upon for any decisions. There's an Excel spreadsheet, I think, on the thumb drive that does some of this stuff. If you do it, you're being your own fool, so don't do that. Don't do that. I just tried to explain, I have worked for actuaries in the past. I am not an actuary, I'm not licensed, so this is all educational only. There you go. Actuaries analyze risk and attempt to price it, but on a group of people. They don't do it for individuals. They do it on a large group and then price it out to different people. An actuary is someone who wanted to be an accountant but didn't have the personality for it. Okay, here's another one. A patient was at her doctor's office after undergoing a complete physical exam. The doctor said, I have some very grave news for you. You only have 6 months to live. The patient asked, oh doctor, what should I do? The doctor replied, marry an actuary. The woman asked, will that make me live longer? The doctor said, no, but it will seem longer. I enjoyed that. If you're going to be an actuary, you've got to have some pretty thick skin because they are kind of very much categorized and generalized as being, no sense of humor. I've known some of them that this kind of could describe, but certainly not all. So what are we talking about? To become an actuary, you have to have a very, very strong set of math skills. You pass a series of tests that can take years. There used to be 10 tests, and some people were still working on all 10 tests 10, 15 years later. It's a long time. The type of math that we're talking about underlines pensions, life insurance, annuities, Social Security, and so much more. Here's some examples. How much should an umbrella liability policy cost? You can get that with your auto insurance that'll cover you up to a certain amount of liability if somebody's walking on your property and cracks their head open or whatever it may be. How do you price that? What's involved in it? How much would it cost an insurance company to include pet insurance in a homeowner policy? I know you've been really wanting to know that. But what about little Fifi? Okay? Given that no one here cares about little Fifi, we'll go on. How many lifetime reservations could be sold by an assisted living facility with a reasonable expectation they won't run out of room? I did such a capacity planning model for a retirement home. You take the census of who all is there, what their age is, and you predict how many of those people are going to die every year. And then you say, if I expect 10 openings, how many guaranteed reservation spots can I sell so that I don't, on average, overfill? If you have a lump investment amount at age 65, at retirement or whatever, how much per year could you get in an annual annuity that would pay for the rest of your life? Okay, so we're talking again about mortality. We're talking about risk, not certainty. A 30-year house loan is certain. If you die, it's still owed, that kind of thing. We're throwing in this idea of things will stop when somebody dies. Here's one. If pension plan assets have grown more than expected, How much can the company pull out if they terminate the plan and pay everything that's owed according to the plan documents? When the stock market goes up, this happens a lot. This happens a lot. That's the kind of thing we're talking about. Essentially, actuarial math adds in the force of mortality into the otherwise certain nature of the time value of money. For example, a traditional annuity might pay you X per year for the next 20 years. The cost today is just a regular old present value. A life annuity would pay you that every year you're still alive and stop once you die. It's kind of hard to send a check to you after that point. It's going to be less than the present value, certain present value, depending on your age, right? Because, you know, an insurance policy, on the other hand, would pay Z at some point when you die. Here, instead of stopping payment when you die, this one pays when you die. So think of it as the other side of the coin. Or if you die between two dates, that's really what term insurance is. Casualty insurance do a similar thing. I worked for a property insurance company for a while, and they're pricing not mortality, but health insurance, morbidity, or simply claims experience. We were doing fire insurance policies. The low end was $25,000 if you had a fire in your house. The upper was $50,000. It wasn't exactly rich neighborhoods. And the fraud investigations would have been mind-boggling. You'd have no idea how many houses burned down that somehow or other the TV had been moved the previous week. Same for health insurance, right? If they rate the probability of coming down with different illnesses, and they do in fact have different price curves for smoker or non-smoker because of statistics. Let's see an example. Here we go. Suppose you have 1,500 18-year-old drivers. There's no risk there. An estimated 300 of these, we're going to assume, would be involved in a wreck in the next year. The average repair costs $1,250. What would the minimum insurance premium need to be? That's not too bad. You would set it up at $300 times the $1,250. That's your total loss, divided by the number of insured, $250 plus profits. Right? That's what you would expect if you priced it out. Now suppose there are 800 males and 700 females in this group, and that the claims experience is going to be different. 250 of the 300 or X, shock, are going to be from the guys, and only 50 from the ladies. If you see people driving on the interstates, try to catch which gender they are, or appear to be. I'll leave it like that. Appear to be, and how old, all that kind of thing, right? But if this is the case, you would price it differently for the males versus the females. So what would the premiums for each be? The males would be $250 times the $1,250 divided by 800, or $390. Insurance for the guys would be higher, and the females would be 50 times the $1,250 divided by 789. Car insurance is cheaper for women. Despite the fact that the stereotype used to be that men were better drivers, claims experience denies that. For non-property calculations, let's get started with this basic point. Forget car insurance and stuff. Let's talk about life stuff, right? Basic point. We are all going to die. I hope that's not a shock. If that's news to you today, I'm glad I was the first one to break it to you. We are all, in fact, going to die. Some earlier than others. I have no idea when I'm going to die. I don't know if I make it out of this room. I don't know when you're going to die. Individually, that's very uncertain. But when you start working with large groups, the law of averages starts coming into play. That's what it's all based on. You're not looking at the individual. You're pricing something for an individual based on the behavior of a very large group of people. Okay? This kind of stuff is all that claims experience forms the basis here of actuarial science. But note as well, life expectancy changes over time. If you are using data as of a certain year, the how long people live shifts over time. Here's a graph, right? Oh, think of this too, right? COVID has changed life expectancy, primarily because so many older people have died. In fact, in 2021 and 2020, USA life expectancy, average life expectancy dropped 2 years. Now, politics aside, pricing has to reflect that. Pricing has to reflect that. Here's a nice curve. This shows the percentage of the original born people that achieved a certain age before dying, 1851, 71, 91, 1911, 1931, and so on. When life expectancy has gone up, that curve pushes outward. 50% of the people in 1851, only roughly 50% of the people got to age 50 in 1851. But in 2011, 80% of the people lived to 73 or longer. That's the improvement that medicine has made, sanitation. The number one thing worldwide that you could do to make people live longer is clean water. That and trying to kill off the mosquitoes in Africa. Don't get me talking about DDT, or you may get mad at me. Oh, but it'll harm the flowers. Well, put a flower on somebody's grave that dies of malaria. Sorry, I had to say that. But you see what I'm talking about with it? If you had a curve from 2017, it shifted the wrong way the last 2 years because of COVID. All right, how does all this work? Let's set up a spreadsheet. I'll show you how they use this. A spreadsheet, it's a baby spreadsheet because I can't do the fancy-dancy things. But let's use a spreadsheet. First, let's put a column in it with ages going from 0 to 100. I go down to like 23 up here, right? Well, you have a group of people born, and we're going to follow what happens to them over time. Now we added a column showing mortality experience. This is usually done by a percentage of people who die before the next birthday. You see how the first year, it's a lot higher than the second year. Infant mortality is still higher, although it used to be a lot higher, right? So you see how it gets lower? You know, it's not near, it gets lower and then it starts going up again. What happens about age 11 that would cause it to start going up? Puberty. Puberty. Especially on the male side, right? Risk-taking starts going up like crazy when guys think they are immortal. And it's primarily guys. It really is. But that's what happens, right? This happens to be the 1980 standard table mixed with 75% male and 25% female. Why do they use that? More policies are sold to guys than they are to ladies. Okay? More policies are sold to men than they are to women. If you are a man, you want that table because since the ladies live longer, that will lower your costs. If you're a lady, you don't want this table because your cost is going to be a good bit higher. What table is your insurance company using? Good question to ask. Okay? This QX column is the percentage of people who don't make it to next year. Isn't that delightful stuff? Anybody who's age 10, I mean, it's only 0.00071, but still. Okay. Next, you start off with a large number of people who were born that year. We'll pick 1 million, and you start knocking them off. So you start with 1 million. You've got down to 996 in year 1 who make their first birthday, 995, and so on. This is as of 1980. I know that was 40 plus years ago. By age 22, you're down to 973, okay? And if you get a question at any point, ask it. Another column is then added that is simply the drop every year. From year 0 to year 1, it's at 3860 over there. You see the 0.000386, right? So it's just multiplying. That's the column of deaths. You got to really have a ability to ignore the morbid nature of all this stuff. Is it any wonder why those jokes are the way they are about actuaries? It'll seem longer, remember, if you marry an actuary. And I had to put this in, right? Is economics really the dismal science? I don't think so. Economists are full of joy compared to this stuff. Now we add in the time value of money. Here's where we start putting in what will turn out to be the kicker as part of it. You put in an interest rate, and you have a column here. The standard nomenclature is VX. Why V? No idea. No idea. But that's just essentially a present value factor for $1 at year 0, $1 paid out at year 1, how it goes down. It may be $1 at year 1. It's equivalent to 94 cents if you paid at the end of year 2, 83 cents at year, 84 cents or whatever year 3, so on. That's all that is. It's 1 divided by 1 plus that interest rate, compound interest. It's a present value discount factor. That's no big deal. 12C does that easy. 12C does that easy. Okay, here's the big step, the more complicated part of it. DX, okay, that column capital DX up there, is the LX number, the number of survivors times that interest rate. This is essentially a time value of money weighted number of survivors. Now stop and think for a minute. If I am paying compound interest, then if I'm paying 1 million people $1, I'm going to pay out, the 94 cents to every one of them. 94 cents times 1 million in year 1, okay? Time value of money, 94 cents is the equivalent cost today at the end of the second birthday. The problem is, right, that assumes all million are still alive. But if I've written the contract where I only pay the people that make it, I'm not going to pay out 94 cents times 1 million. I'm going to end up paying 93.9 cents to the survivors. Divided by 1 million, 93.9. My cost goes down because some don't get a check. So this column is the time value of money column times this death column over here. And it goes down, down, down. Now, it doesn't affect it all that much early on because people don't usually die as quickly remember the curve, right? You got to get way on out, so to speak, on the curve before that starts taking effect. I knew there was a risk deciding to talk about this today, but now we have the NX column. Okay, this is the last column. Kind of hear a NX column. This column, think of this as the sum of this from any given age to the bottom of the chart. Okay, this is the time value of money, survivor-weighted total dollars that are going to have to get paid out. So if I am looking at people who are from 3 years old to 100, I'm going to end up paying time value of money discounted, survivor discounted, $14 million out from age 3 to the end of life. That's how many single dollar bills I'm going to hand out to the survivors of this original million, only to people who make it every year, right? If there were no time value of money, if I was just paying, it'd be $1 million every year because I'd pay $1 million whether somebody's alive or not. If I'm doing time value of money, I'm paying 1 million people discounted time value of money every year, but I'm not doing that either. You're not going to write a check to somebody who's been dead 60 years. You get relieved of that obligation. You're only writing discounted checks, cheaper checks because of inflation, time value of money, to the people that make it to the next birthday. Richard, I'm taking a chance here.
I had to leave the room for a moment. What was the basis for the 100?
You just assume everybody dies off at age 100.
I mean, how do you assume that?
You put 100 on the table and you put it in a spreadsheet. No, seriously, the tables usually knock off everybody at year 120. That's what they usually do. I did 100 just to keep my math a little easy.
Oh, okay.
That's no big deal.
But it could be a number depending on who's doing it.
It could be, the table could extend beyond 100. That's totally just arbitrary for me. Good question. Very good question.
Question.
Roger.
VX column, is that derived from the previous columns or is that something independent?
The VX column is 1 plus the 6% to the power of what year we are, reciprocal. So if you take 1.06 and do a reciprocal, you get 0.94.
So it's like like inflation.
It's a present value factor. If I'm going to pay you $1 next year, what's the real cost today? 94 cents at 6%.
Ooh.
That's the time value of money factor. Okay, so again, if I'm talking about people that have made it to age 15, I will have to pay out in time value of money terms. Remember, I'm at year 0 right now. I'm looking ahead. To anybody that makes it to 15, what's my today present value I'd have to pay to anybody that makes it to 15 who keeps living? 6.8 million over there.
So that's assuming you start with $1 today. It's earning 6%. 15 years from now, it's worth more, and so you only need to pay off 41 cents of your Today's
Try to think about it, yeah, in a sense. Try to think of it the other way. $1 15 years from now is only worth 41 cents today, or whatever it is.
yeah, okay.
Do it that way, and it'll be easier to talk through.
But so you're paying that
Only to people who are still alive over there.
right, and the DX, the 939 is 94 cents times 1,000
Times the million.
times the million.
It's this number times that.
Okay, what I don't understand is why are you paying?
I'm sorry,
people who are
this
alive?
number times that. It's times the 996.
Why are you paying the people who are alive instead of?
Because it's a life annuity. This is not insurance.
Oh, okay.
This is an annuity. Insurance is the flip side of this stuff.
Got it. Okay.
Sorry.
That's what I missed. Thank you.
Now, again, why do so many people die in through here? Well, you know, this terrible joke. And by the way, for anybody watching or anybody here in person, if you've had, I should have said this at the start. If you've had somebody that has died recently, I'm really sorry. I'm not really trying to insult you or anybody listening, but do we really want to talk about this stuff without having to try to throw some humor in there? I mean, I don't. So here's my last joke, and then I'll be serious from here on. What's the #1 epitaph on a tombstone for a teenager? Here, hold my beer while I try this. It's that type of dumb risk that causes so many teenagers to die. Right? It really is. I mean, the Darwin Awards, you know, are look stupid because people are stupid. So anyway, again, if you've had a loss, I'm really sorry. I lost my mom 4 years ago. I still have to talk about this stuff. It's okay. So here we go. This is the last column. It's a calculation on the other ones. This is the cost at this age for a life annuity if you were to buy one. If you have a brand new baby and you want that baby to get $1 a year for its entire life, whatever that's going to be, you'll pay $16.05. $16.05 today. Oops. And so if I am 20, $15.43. Why will $1 a year be cheaper at age 20? Well, this is an annuity starting at age 20, right? I'm 0 today. You want to set up your college child to get $1 a year when they turn 20, you're going to pay $15.43 and so on.
Per dollar.
Per dollar of whatever you want the annuity to be. That's another good point. This is a price per dollar. Life annuity. It's determined by this little AX. I have desperately wanted a calculator that would have the AX built into it. Change the interest rate and give me a life annuity. At one point, I had hoped, I tried to talk to Katie Wasserman, since she's another 12C expert, better than I am, when you could repurpose the 12C with the kit to pre-program the data for the mortality table in it and have it give me life annuities. We'll talk about that in a little bit. I bugged Eric about it on hpcalc, but it would be nice. There'd be uses for that, pensions and life insurance. So, all right, keep going. How does this compare to a certain normal annuity that's going to pay you $1 a year for 100 years? Well, here you go. For a 3-year-old buying a regular annuity that would pay $1 from age 4 for 96 years straight. Doesn't matter if they die. If they die, it goes to somebody else. Costs you $16.61. If you have a 3-year-old, you're going to buy $1 a year for the 96 years. That's what it costs. If you do the life annuity, it's only $16.04. Why? Because the time value of money in that case more than knocks off any mortality effects. You got 96 years of interest. Okay, everybody will die at some point over there, but interest is some, you know, interest and taxes is another way of saying this stuff. Time value of money, as I say, kind of trumps the effects of mortality at the very early end of the table. Jay.
Also, just clarify, the regular annuity keep paying, but life annuity stops.
Stops when somebody dies.
Yeah.
It's an annuity for your life. The other one is an annuity certain. Okay.
Now, was it 6% pre-Biden?
We're going to put you in timeout. All right, there's a bigger difference for a 50-year-old. Suppose you're 50. If you buy a regular annuity from age 50 for 50 years, it costs you $15.76. It'll pay 50 years, right?
Whether you live live or not?
Whether you live or not, regular annuity. But if you buy a life annuity, it's only 12, 13. Why? They don't think you're going to make it to 100. Time value of money's in there, 50 years of it, but the mortality has started overpowering. The curve's dropping faster of mortality. Okay? Finally, if you're talking about an 80-year-old buying a life annuity, regular annuity for 20 years. Certain annuities for 20 years, it costs $11.47, but a life annuity, $4.86. Mortality. Mortality. In this case, right, it's this trade-off. But without this kind of math, you're dealing with certain annuities and you can't really price things out the way they ought to be. I don't want to buy an annuity that'll stop when I die that's only using interest. My wife doesn't want to do that, certainly, right? This is the life annuity. Stops when you die. The other side of the coin is it pays when you die. That's insurance. Same math underlies it, it's just you turn it around the other way. Okay? Thoughts? For large groups, this works out well to spread risk. You have to do this kind of thing if people want to protect their family from an extreme event that is unlikely to happen, but substantial if it does. That's what insurance is all about. Everybody's taking on a piece of the risk to protect the very unfortunate few, certainly at early ages. And this other idea is to, everybody's buying annuities. Annuities get a bad rap, I understand.
Yep.
In some ways, but if you want to have a payment and you want to have it, Social Security is an annuity, it pays until you die. I mean, this is the math that underlies this stuff. Pitfalls, the biggest is changes in mortality. That curve comes in and out, right? If the bubonic plague, the Black Death, changes and suddenly starts wiping all of us out, nobody's going to care if the insurance companies go under, but I mean, it's going to be a different ballgame.
Now, didn't COVID have some effect?
COVID has changed some of it. It did drop 2 years off the average, but it was different in that it changed the curve at the very, very far end. The overwhelming majority of people who were affected with mortality from COVID were at the very far end of that life curve. It did not change it, push it down as much in the early and middle. It didn't. But it affected it enough that that curve on the tail end came in 2 whole years. 2 whole years. Other variations, we looked at life annuities. There are endowments, kind of like the insurance, right? Pay X when you die. There are joint annuities. It pays X to you, and then if you die, it pays Y to your spouse. Or it pays, there's usually a 2/3 joint annuity, or a 100% joint annuity, or a 50% joint annuity. They use the tables, and it's just more complicated math. Same stuff, same stuff. There are certain life annuities that would pay you, for example, X dollars for 20 years and then pay you as long as you live. You're guaranteed 20 and then it keeps paying. That's not, sometimes, right? Well, I don't want to, if I die next year, I don't want all the money to go away. So you set up a certain period and then it'll continue with life afterward. Other considerations, reinsurance is a big deal. If you're writing all these policies, the last thing you want is to be unlucky as an insurance company and have all of your clients all be on an airplane together that runs into a UFO or something, right? So they take their pools and others buy pieces of it so that nobody is exposed. If it's a good idea for potentially me to have insurance in case a bad thing happens to me and my family's affected, the insurance companies are just the same situation, just at a bigger scale. Reinsurance. What's the math look like? It is not easy stuff. We did it in a spreadsheet, but I mean, dx equals that vx times lx. This is the sum of all the dx's. Look at this nasty stuff. The most elementary calculation. Look at this. The most elementary one using commutation functions is to note that, well, okay, I eventually figure that out. Okay, I understand that. And then you get this thing, the life annuities, the sum from t equals 0 to infinity. Sorry, we really should say 120. Of this kind of mess, I mean, you've got to really understand your math. Those are only summations, but on like the 3rd page of the actuarial textbook, it's doing integrals of all sorts of stuff. And I was like, what? A few more things. You get that kind of thing up here at the top. I was not a math major. I know that's pretty obvious. Right? I was a math minor. And I will confess, I took the first exam 3 times. Failed it all 3 times. You had to have a 60 to pass. The first time I took it, I had a 59.
No.
And this is the reason I failed it.
And the second time you had 57?
It dropped. Yeah, I wasn't as motivated. I couldn't do it.
Oh.
But this is called a directional derivative. I still don't know what that is. And when I would look in the textbooks for an example, I think, okay, you get on the test, it wouldn't be like the textbooks. It would say, what's the directional derivative of this thing in the direction of some data point, 2, 3. It was never in the books that way, so I never did figure out what they were talking about. Roger, I know you could tell me.
They don't teach it as much. You're right. They don't teach it as much.
They caught me.
Math books.
That's why I didn't pass the test the first time. I know why. I know I didn't know it, and I missed it by 1 question. But, yeah. It was the pain of my actuarial test sitting. I hate you. So how about on calculators? I've said there are no, could be done on a 17 or 19, get a list of stuff. You should be able to build some formulas. I would love to see somebody do that. I would love to have that. I really would. I'd play around with it. There are some RPL ones. There's 2 packages on hpcalc.org. Right over here, you see that says DX. It's doing insurance, single premium, and all this kind of stuff. Yeah, I have not downloaded that because I don't have a serial port to get it on my 48, and I don't know if it works on the 50 or any of that stuff, but I plan to sometime.
That is the 51.
Is that
is for the 50.
The 50G? Excellent. I can put it on the NFC card and try it out. I just wanted to talk about it. For one thing, who knows, right? People may think, well, I am going to die one of these days, and maybe you will avoid some sort of unpleasant situation for people that may depend on you, right? But on the other hand, I didn't recall anybody ever, we talk about time value money all the time, but in some ways, if we're talking about people, mortality trumps the time value of money, and I thought it would be worth talking about what goes into some of that. Richard.
Well, it says a lot of data. Why couldn't they put in, say, 3 or 4 sets, which are more commonly used, 100, 110, 95, so, and put those in tables in the machine?
You would have, the question is, you use a lot of data. He's wondering, can you do subsets? You could if you were only writing policies of people 65 and over.
No, the whole set.
But you still have to have 120 data points, and then you've got to compute those other columns. And that just gets ugly.
Oh, no.
Because you got the column of survivors, you've got to compute the interest. You could compute that, but then you got to have it multiplied times the interest factor. I mean, it just gets complicated. Nobody's done it. So here's a challenge. Maybe that'll be the programming contest. You want to start on it today? It's due next year. Any questions on this? I know you're dying to ask.
But
Throw some tomatoes. Come on, hit me. Any questions, anybody? I know y'all want to.
The
Dave.
interest rate doesn't have as big an effect as the mortality table.
In the end, it does not.
Interesting.
And what interest rate is your insurance company using for their time value of money? If they're saying 6 and we had 2% for years and years, I don't know, right? But ask questions. Anything else? Eddie.
What is the preferred interest rates for the actuarial companies?
I don't know what it is now. It should be higher than it was 2 years ago, but I don't know.
Is it based off prime one way or another? Something?
I don't know the answer to that. It should be, but I don't know. Jay, I'm going to go around there by Jay.
Is there some soft, like standard answers you can check your implementation against?
I had trouble finding a spreadsheet that was done already. They don't want you downloading those apparently. Why? I don't know.
Because they're selling.
But I did my best with it. Some of those numbers could be slightly off. I mean, that's the general stuff. That's why I had the big fine print. Don't use this to make any decisions. But I had been involved in a pension plan termination, paying out people what they were owed, and the company scooping off anything more than that. I was involved in that. I was involved in the capacity planning model. I mean, I did a lot of that stuff, but I programmed it all in BASIC, and I don't have that anymore. Back there somewhere, anybody?
Well, those different terms you talk about, like XA, the 2 actuaries talk to each other. You say, what XA do you use? Is that like a common term? Like I might use interest rate or something?
Maybe, probably. It has been, by the way, it has been 30 years since I worked in the field. I haven't done anything as a grunt. People still dying, unfortunately. David, last question.
If you go out and you're trying to buy an annuity or whatever, any tips on how to tell if you're getting ripped off?
Well, this table, I would think what interest rate are you using? What mortality table are you using? You could probably use that, and if it's $16 and they're charging you $50 per dollar, that's probably high. But get multiple quotes. Get multiple quotes. All right, listen, thanks everybody.
Thank you, Jane.